Hello. I'm Mrs. Jacobson, and today we're going to cover 15.3, the area and the definite integral. We're talking about the area under a curve. Now if we have the function x minus 2, and we want to find the area under the curve from x equals 2 to x equals 6. First thing, graph it. We're only going from 2 to 6. Now we know it's a straight line, but we could graph it using our calculator. I already plugged it in, so x minus 2. And if you are going to graph it, a window you could use -1, 8, -1, 6. You have this graph. You can see it crosses at 2, so at 2's here. And at 6, well, we could go to the table and see where it's at. 2, it's at 0, 6, it's at 4. So 2, 0, and 6, 1, 2, 3, 4. There's our line. So we're looking for this area under the curve. One way of doing that is using geometry. One half base times height, because that's the area of a triangle, and we have a triangle. So we have 1/2 our base, 1, 2, 3, 4, and our height, 1, 2, 3, 4. Gives us 8. So the area under the curve is 8. Now other ways of doing it is to make rectangles. So before we had formulas for geometry, we made a bunch of little rectangles, and you add them together and it'll find that area. It's an estimate. Now if we're going to do it with 4 rectangles, that means we're breaking this up into 4 sections. So we need to find our change in x, delta x. And the formula is b minus a over n. N's the number of rectangles. And a and b, a is your smaller value, b is the larger value. So for this problem, change in x is 6 minus 2 over the number of rectangles, which is 4. So that means our units are counting by 1. That's what we're going by, is 1. Making those 1, 2, 3, 4 rectangles. Now one way of doing it is using the left endpoints. When you're looking at the rectangle you're using from the left, So you're starting on the left and using 2, 3, 4, 5. We're stopping at 5 because we want 4 rectangles. 2, 3, 4, 5. And then you plug in your Y value, because what you're doing is you're finding this height. That way then, this works. Well, this one we're losing that whole rectangle, but here then the rectangle would be here. So notice it's going to come a little short because the area we're finding is this. Because we're starting on the left and going with that height. So it's going to come short. To find these values, you already have it in your calculator. Go to table and put 2, 3, 4, and 5. And there's your values. 0, 1, 2, and 3. Now to find your answer, you add up the Y values. Remember, this means to sum. So add up the Y values and then multiply by your change in X. So if we add these up, we get 6 times our change in X, which was just 1. So this did come up short. We said the area under the curve is only 6. We know by the triangle it is 8. But it's just a way of getting an estimate. Well, what happens instead of using the left if we use the right? We can do the same thing, only start on the right. 6, 5, 4, 3. And again, we stop at 3 because we only want 4 of them. 1, 2, 3, 4. This time, we're using the height of 6, and then this one. So we're using this higher height for our rectangles. Notice the rectangles, which means we're going to be over. So this one's going to be a little bit higher. Plugging them in, the only one we don't have is 6. So 6 is 4, 3, and then 2, and 1. So we add them up, multiply by our change in X. So they add up to 10. So it's a little high. Another thing we sometimes do is find the midpoint of these two. Let's label these A, B, C. So average parts B and C. So this one was too low, this one was too high. Well, what if we take the middle, average them? And that gives us 8, which, because this is a triangle, it does give us the exact value. Sometimes it will not, but it will be closer. So averaging the two together is another way. Okay, so this one was right. Of course, there's one more way. Another way is to use the midpoints, because if we look at this, instead of using this end, which is too short, and this end, which was too tall, what if we went in the middle and made a rectangle. The part that's coming short will fill in the part here. This part will fill in this one. This and this. So it's filling in the part that's missing. So you use the midpoint. Oh, we used Y. So to use the midpoint, you're going in between them. So if this is 3, I want in between 2.5. So you just add them together and divide by 2. Once you get the first one, you can just keep adding your change in x, which was, in this case, 1. So we could keep adding 1, 2.5, 3.5, 4.5, and 5.5. We only need 4 because we want 4 rectangles. So then we go to our table. I'm going to delete these. And then I want 2.5, 3.5, 4.5, and 5.5. 5, 1.5, 2.5. And then we add them up, multiply by our change in x, and we get, oh, this is 0.5 now that I look at it closer. It's a 0.5. So that's 1, 2, 3, 4, 5, 6, 7, 8 times our change in x, which is 1. It gives us 8. So it's different ways that they use to find values. Now what the next section shows you is using the integral. And we're going from 2 to 6. But let me give you the formula first. So if this is f of x, when you take the integral, then it's f of the top one minus f of the bottom one. And you don't have to worry about the c's because the plus c here minus the c here cancel. So we don't have to worry about the constant when we're plugging in numbers. So if we take the integral of this one was x minus 2. And we're going from 2 to 6 because that's what we had said, 2 to 6. When you take the integral, you get x squared over 2 minus 2x. We don't need the plus c because it'll cancel. But I'll put it in there so you can see it canceling. And we're going from 2 to 6. Now to solve it, plug in the top number. 6 squared over 2 minus 2 times 6 plus c. Minus, plug the 2 in. 2 squared over 2 minus 2 times 2 plus c. And we're going to get 36 divided by 2 minus 12. Minus 4, negative 2 plus c. 6 plus c plus 2 minus c. The c's cancel. 8. So it's another way of doing it. Now the c's, they will always cancel, so you don't, when you're plugging in values, you don't need the c. Let's try another one. Okay, so I want to go from x equals 1 to 3. First thing I want to do is graph it. Now I left the space in here because I already know what my change in x is. Because it's 3 minus 1 over however many rectangles we're going to do. And we are going to do 4 rectangles. So we're counting by halves. And we're going from 1 to 3. Now the first thing we need to do is graph it. For the window, use -5 fives. So I have my 1 over x, and my window, -5, 5, -5, 5. Now notice there's a graph over here. Well, that doesn't matter because I only want to go from 1 to 3. So you don't even need this part here. But if you want it there, there's a graph over here. But we're only going from 1 to 3. Right there. Okay. Let's use left endpoints. Now, what you want to remember is that we're counting by halves. If we look at this, the left endpoint starts at 1. So it's 1, and then count by halves. 1.5, 2, 2.5, 3, 3.5. But I stopped because I only want 4. If I wanted 5, I'd keep going. If I wanted 10, you'd go some more. We only wanted 4. And then you plug them in. Go to my table, and I plug in 1, 1.5, 2, 2.5. And I have my values. So we'll go with 1.7, what did I do? 0.67, 0.5, and 0.4. You add them up and multiply by your change in x. So if we add these up, we get 2.57 times our change in x, which was 1/2, which gives us 1.285. The next one is the right endpoints. Well, the right endpoints start on this end. So we're going 3 and going downward. So 3, 2.5, 2, 1.5. Keep subtracting that half. And you stop when you have 4. So then we'll plug these values in. 3, 2.5, 2, and 1.5. And we get 0.33, 0.5, 0.4, and 0.67. Add up the y, multiply by your change in x. So if we add these up, add those 4, you should get 1.9 times 1/2 equals 0.95. Okay, another way is to average those two. To average them, we take the 1.285 plus the 0.95 and divide by 2. And we get, we'll find the actual value in a second, and we'll see what's the closest. But right now we have this value, this one, and this one. Now, of course, there's one more. We can do the midpoint in here and see where it lands. Let's see, we're doing 4 rectangles. So to use the midpoint, you find the middle of the first one, and then you just keep adding your change in x. So if we find the middle of the first one, we're going between 1 and 1.5. And divide it by 2. So you should get 1.25. Now you don't have to worry, you don't have to find the midpoint of all of them, because once you find that, you just add your change in x, which is 0.5. So it's 1.75, 2.25, 2.75. So I added these and divided by 2, and I got 1 1/4. And then I kept adding a half. And I stopped here because 1, 2, 3, 4, I want 4. It doesn't have to be 4, it's just a number I was choosing. It just works out nice. The more you have, the more accurate it is. So then we go back up, we put 1 1/4, 1 3/4, 2.25, 2.75. And I rounded everything 2 decimal places. So we have 0.8, 0.57, 0.44, and 0.36. I wasn't hitting plus. There we go, 2.17. There was something, oh, it's because of the extra 4. Okay, 2.17. Adding them up. But then don't forget your change in x, which was 1/2. So before we had anti-derivatives or integrals, we used this process of rectangles. And we found that the more and more rectangles we got, the more accurate it was. Now to use the integral, we're going from 1 to 3, and our function was 1/x. Remember, 1/x, we'd have to rewrite it as x to the -1. Which then if you try and add 1, you get 0, and you can't divide by 0 because x to the -1 is a special case. It's the natural log. So it's the natural log of x from 1 to 3. And then it's your top minus your bottom. natural log of 3 minus the natural log of 1. If we plug that in, natural log of 3 minus the natural log of 1. Get 1.0986. This one's pretty close. I think it's the closest. But that's one way of doing it, using area or rectangles under a curve.